spend today and tomorrow on section 2.4, okay, which is what I just gave you. So tomorrow we'll get a handful of other examples. Wednesday, I want to start 2.5. Do that on Wednesday and Thursday. Second half of Thursday, I want to review a little bit for a test on Friday. Okay? So chapter 2 test will be Friday. If you read your email today, that is in your email. All right, if you guys were to compare the red steps here, for how we solve equations with variables on both sides, those red steps are identical. Now, I didn't cut and paste them, but if we went back to section 2.3 and looked at the steps here, 1 through 6, okay, these are identical to what I just gave you in front of you, okay? So we've already seen these steps. We've already applied most of them, okay? But if you remember going back to section 2.3, we didn't do steps 2 and 3 very often, if at all. Okay, so we're gonna address that a little bit, and we didn't do much of steps 4 and 5. It was already done for us. They were already separate. If you look at all these examples, you see variables showing up on both sides now, right? Okay, that's a little bit different than what we've seen in the past. Okay, so like always, distribute if necessary. You might do that multiple times. You see in a couple of these. Towards the bottom here, okay, you got distributed on the left-hand side and on the right-hand side. You could have as many cases of the distributive property as they want. They could have 13 different distributive property processes inside any equation. Okay, it's kind of crazy, but it could be something we see. Once you distribute, you are then going to look at one side of the equation. Okay, and I got there, look at the left-hand side. And you're going to go look through all the constants. Remember, those are the ones that do not have the variable. Okay? And you're going to either add or subtract, okay? Combine like terms. Okay? Do the order of operations with addition and subtraction. Okay? Then you're going to go find all the variable terms on that side. And you're going to add or merge those together. Okay? After step 2, okay, you should have a constant and a variable term, one of each on the left-hand side. Okay? Then you're going to do the exact same thing on the right-hand side. Okay? Combine all like terms on the right-hand side. Steps 4 and 5. Okay? If you have constants left over on both sides. Okay? Meaning that, maybe in step 2, maybe some of my like terms added to 0. And then I don't have a constant on one side. Okay? But if you have constants on both sides, you need to get them all on one side. Okay, and we're going to do that through the use of the additive and subtractive properties of equality. Okay, so we're going to have first example down here. In this question, step 1, step 2, and step 3 have already been done for us. So we're right now at move all constants to the other side of the equal sign. So you see you got a 2 on the left and you got a 14 on the right, correct? We don't like that. We need to get either the 2 over with the 14, or we need to get the 14 over with the 2. Does that make sense to everybody? Okay. Now, if you're ever going to take something and make it jump across the equal sign, you use the inverse operation. So if I want the 2 to jump over to the right, I'm actually going to subtract 2. If I want the 14 to jump over to the left, I'm going to subtract 14. Does that make sense? If you look at the middle one there, with the p's, if I want this -7 to jump to the other side, I'm going to add 7. Does that make sense? Okay. So that's step 4. You move all your constants to one side of the equation. Okay. Once you've decided which side you're going to move them to, and it doesn't matter. You move most to the left, most to the right. You are then going to move all your variable terms to the opposite side. So if I move all my constants to the right, I'm going to move all my variables to the left. I moved all my variables my constants to the left. I'm going to move all my variables to the right. Is that okay with everybody? Constants and variables need to be separated on either side of the equal sign. Okay? Once you have that, once you've done that, your equation is going to be a one-step equation. You're either going to divide by the coefficient that's out in front of the variable, or if it's a fraction, you're going to multiply by it specifically. And then you solve for the variable. Okay? Those are 6 steps that will get you the correct answer every single time. Okay? Here's the thing about providing steps in mathematics, and I hate doing this. Okay? And every time I write one of these worksheets out, I'm always hesitant. Do I do it this way? Do I not do it this way? But I think giving you steps at least gives you something you can go back to if you get stuck. Okay? But what I need you to understand is that those steps are not set in stone. Okay? For instance, I think this should make sense. Does it matter whether I do step 2 or step 3? Do step 2 first and then step 3, or can I work on the right-hand side first and then work on the left-hand side? That kind of make sense? Those 2 steps are interchangeable. Okay, that doesn't make a whole lot of sense to really discuss those 2. But if I look at 4 and 5, those are something we should discuss. 4 says you have to move the constants first. 5 says you move the variable second. That doesn't matter. You can move the variables over first and then move the constants over. Okay? Those steps are what we say are independent of one another. One of them does not impact the other. If you do step 4 first, that's fine. If you want to do step 5 first, that's fine. That make sense to everybody? Okay? And in all actuality, you don't even have to do the green ones before you do 4 and 5. It makes sense to be less subtraction addition. But those things are not set in stone. Okay? So as we go through the year, and you say, well, Mr. Fay, September 30th, you told me I had to do these 6 steps in this order. My hope is that we start to learn the system better, and you start to understand why the order can change, and maybe why one question we use maybe order A, and then the next question right after it, we shows, okay, let's use order B instead, because it's just the way it sets stuff up to be solved a little bit easier that way. But if you in mathematics kind of just try to kind of drill steps into your mind, I think you're going to miss out on some stuff. Okay? But like I said, the steps are like a safety net. Okay? If you can't remember what we're doing, go back to the steps, walk through those, and they should get you to the answer. Does that make sense? Okay? These questions, there's 3, 4, 5 different ways you can solve them. Okay? My overall hope for you is that you learn this. When we approach an equation, the overall task is to get all the variable terms on one side, all the constant terms on the other side. Okay? And then that will generate a one-step equation where I can just divide by the coefficient and multiply by it. Okay? So if I look at this, okay, you get to make the choice. Do you want to deal with constants first or these variable terms first? And I'm just going to say, I'm going to force us to work with the constants first. Okay? That's kind of what my first 6 steps were saying. So, our constants. Remember, those are the non-variable parts, right? Now you have to make a decision. Do you want the 14 to stay where it's at, or do you want the 2 to stay where it's at? 14. Okay, so if the 14 is going to stay where it's at, then we need to move the 2. Does that make sense? Yeah. And we're moving it across the equal sign. Okay? So, you're going to hear some people say, move it. I like the idea of that we're going to make it go to 0. We're going to dissolve this 2 here. So that helps me remind myself that I'm subtracting 2. So subtract 2 from the left. But what I do to the left, I have to do to the right. So now I'm going to subtract 2 to the right. Now here's the thing. We got to pay attention and still understand like terms here. Because I go to 2x plus 14 minus 2, I got to realize that 14 and the minus 2 are like terms, right? I can't subtract 2x and 2 because one has an x variable and the other doesn't. Does that make sense, everybody? So I align them that way. I make sure constants with constants, variables with variables. Okay, so because they're on different sides. So when we write this, those are going to vanish, go to 0, right? So it gives you 5x on the left, 2x plus 12. We agree with that? Okay. So the next step says, now that you've moved all your constants to one side, and that is being represented by that 12, right? So that thing is on the right-hand side. It's all my constants, the entire problem, I've merged to give me that 12 on the right-hand side. Okay? With some thought in mind, the overall objective is to get the constants by themselves and the variable terms on the other side, right? So that 12, I'm going to leave there. I'm going to highlight it and say I'm going to leave that there. So what needs to go away? Okay, so I need to turn this 2x into 0, right? So I'll minus 2x there, and then I'll minus 2x there. See how that's the idea that we're going to move this 2x to that side. And it gives me now 5x minus 2x is 3x. This went to 0, but then I had my plus 12. You see how that procedure, that all your variable terms on the left and all your constants on the right, and now it's a one-step equation. Now it's 3x equals 12, so then divide both sides by 3, and x is 4, right? Okay. I'm going to come over to the side here. And I'm going to start the problem over again. And I just want us to understand that you have options. Okay? And when we have options, it's a good thing. At the same time, it's a bad thing. You might start thinking, I've got so many different ways I can do this. I just don't know which way to go. Okay? So I want to prove to you that those 6 steps are somewhat interchangeable. You guys said we wanted to move the 2 over, right? What if I did this? So now I have 5x. What's 2 minus 14? Negative 12 is equal to now 2x, right? Okay, so that idea, then I want that, because that's my constant, I want that to be by itself. So I need to, like Boston said, subtract that 5x over, because those need to go away. Now 2x minus 5x is negative 3x, right? If I divide both sides by negative 3, does it still give me x to be 4? Okay. So that was a different approach, right? A little bit different than the red one. Now they're very similar. Let's do one that is not even, in my opinion, I think close to being similar. Let's go 5x plus 2 equals 2x plus 14. We were subtracting the constants first, right? Let's do this. Let's say that this 2x, let's subtract it from both sides first. What's 5x minus 2x? 3x. I didn't do anything with that plus 2. And now I've got 14 here, right? Now remember what the overall objective is. The overall objective is to get my variable terms and my constant separated, right? So now I always see that the 3x, the only thing that has a variable left in, right? So now what do I need to move to the other side? The 2. Okay? So I subtract the 2 from both sides. Minus 2, I get 12 here. I divide by 3 again. Does x still end up being 4? Okay? Now, the other way that I think you can do this is you can subtract 5x from both sides first, and then move 14 to the left. And that would still give me x equal. I think there's 4 different versions of this problem that we can go through, procedures that we go through, to still get 4 out, right? And that's what I want us to understand, is that there's multiple ways. And what we do in class together, okay, if that's not the way that you always do it, understand that there are different approaches. Okay, and if something doesn't make sense, let me know. Okay,
or you try something and say, hey, this is the way I've been doing it, does this really work, and why does this really work, okay? We can understand that idea, that main objective of getting your variables on one side and your constants on the other side. You should be able to solve any problem you ever come across. So I want you guys to attack that middle one there with P, okay? See what you come up with. Give you about 2 minutes to do that. So what'd you do first? Anybody? Boston? Okay, so you said that you were going to work with your variable terms first. So you said you're going to take this 3p and subtract it from both sides, right? Okay. Now understand, guys, that when we do this, you're going to want to line these things up so that they're like terms, okay? It would not make sense to do that, right? Okay, because the 2 and the 3p are unlike terms. So make sure we line those things up. So subtract 3p, so I get 4p minus 3p gives me 1p. Then I got my plus 2 because I didn't do anything with that, right? That went to 0, and then I've got my minus 7, right? Now what? So now it makes sense to subtract 2. And what's negative 7 minus 2? Negative 9, good. Okay. Perfectly fine. Did anybody move constants first? Okay, so which constants did you guys move first? Okay, is that what you did? Okay. So, let's see here. My eraser's not working the way it's supposed to. Do it this way. Okay, so so you move the 7 first, so how'd you move the 7? Added it, right? So we all agree that we understand that when I say move it, basically we're trying to get that to go to 0, right? But when I add something to the right, I've got to add the same thing to the left. So we saw a 7 over here, now it's going to be kind of moved over here, okay? So now I've got 4p plus 9 is equal to 3p. Now what'd you do? Good. Subtracted 4p. I'll come back to what you said because you're not wrong. So I subtract 4p because your idea is to get that positive 9 by itself, right? That's the constant we got to get by itself. So you remove the variable over, so give me this. So what was the last step you did then? Good. Divide by negative 1. And it's going to turn this to a negative 9, and that to a p, positive p, and that's fine. Okay? Now, at this stage here, where I had 4p plus 9 equals 3p, you can subtract 3p from both sides. And this is the thing about mathematics, is that as long as I do it to both sides, it's fair game, right? And how many p's would I have on the left now? I just have 1p, and I have a plus 9. Now, this is the reason why I'm cautious of doing this. What do you have left over here on the right? Say again? 0p, which is just 0 times p is just 0, right? Okay? So there's two issues that happen there. A lot of people write 0p, which is right. It's 100% right. But remember that p is a number, so 0 times a number is just 0, right? Or I get people say, well, 3p minus 3p, you get nothing. And they just eliminate the right-hand side of the equation and think, well, now I got 1p plus 9, and I don't know what to do. When you get nothing, nothing is represented numerically as 0, right? So you got to have that. So now that I've done that, can I now get this p by itself by subtracting 9 from both sides? And does it still get me the same answer? Okay? Those are valid approaches. And if you went that second route, you got to have built into your mind several things The main thing being we're trying to get variables on one side, constants on the other side. Okay, and that's what we need to do there. We got 1p plus 9 equals 0. Okay. All right, so let's do it. This one's an interesting one. And there's a couple here that are like this. Okay. What do you want to do first in this one? Boston? Add into both sides? Okay. Did you add this in, or do you want to add that in? You added, so you went plus n here and plus n there, right? So that gives you negative 24 equals 5, right? Negative n plus n, that goes to 0. Those are opposites. Okay, negative 24 equals 5. No variables any left over anymore, right? You could do this. It doesn't matter. At either stage, you can answer this. But could I add 24 to both sides and get 0 equals 29? Okay. Either one of those is fine. But when you get rid of all your variables and you're left with a phrase like this, negative 24 equals 5. If you have $5 and I have negative $24, do we have the same amount of money? No. So what kind of statement is that? Is that a true or false statement? That's a false statement. Okay? And this is something we always got to be on the lookout. As you're solving equations, it doesn't happen, I would say out of every 100 questions you get, maybe 3 or 4 of them are like this. Okay? But if you get down to a statement where you're left with a comparison of two numbers, you have to ask yourself, is that comparison true or false? Negative 24 equals 5 is false. 0 equals 29 is false. And what that means to us is that we have no solutions. Okay? Sometimes you might see it written that way, a circle with that little slash through it. Okay? But we have no solutions. There is not, there is no value for n. Any number that you want to pick, you cannot plug it in to the left-hand side and plug it in the right-hand side, and it spit back a true statement. Does that make sense? So, the first two examples had one solution. This one has no solutions. Let's do this middle one here in the second row. 9m minus 4, there's no like terms there, right? Would you agree that that and that are like terms? What are you going to add those together to give you? Okay, negative 3m plus 12m is going to merge to 9m, right? And then you got that plus 5 still, correct? What do you want to do next? Okay, subtract 9m. And you're left with negative 4 is equal to 5. Well, that's kind of like the last one, isn't it? You're left with a numerical comparison of two numbers. If I owe you $4, but you have $5, do we both have the same amount of money? No, that's a false statement. So how many solutions? No solutions. Spell solutions right. A lot of times you'll see solutions, SOLN apostrophe S as like the abbreviation. Okay. I'll let you work this one because we're running short on time here. I'll let you work this one out here, but this one also should end up being no solution. Okay, let's get down here real quick because this is another special type of equation. What do I have to do what does the algebra tell me I have to do first here? Distribute. So you get 10x plus 12 on the left equals what on the right? Okay. So at this stage, you could actually quit. You could quit here because why? Okay, good. Because both sides are identical, right? Okay, when things are identical, you see that next word down there on your worksheet, it says identity, right? No matter what you plug in for x here, you're going to get the left-hand side equal to the right-hand side. If you want to go further, maybe we subtract 10x from both sides. And now we can actually make that comparison kind of similar to the last two. Well, we've got a number equal to a number, right? Is that true or false? That's true. Okay? So what happens here when you're able to make a true statement? Like Annika said, you have an infinite set of solutions. You can plug anything in here for x that you want, and you're going to get the same value on both sides. Okay, so an identity, folks, an identity is an equation in which you get a true statement regardless of what your variable value or quantity is. You can plug anything in you want, and you're going to get a true statement back. Does that make sense? Okay. That's something we're going to pay attention to. When we're working with these types of equations, you can have one solution. You can have no solutions, or you can have infinite solutions. Now, the no solution, infinite solution cases, those are rare. Okay. Like I said, out of 100 questions, you might get 2 or 3 of those to pop up. So because of their rarity, a lot of times we neglect them, forget about them, when we come across them, we get confused. Okay? But they do exist. Bring that worksheet tomorrow. We got a little bit further in the last class. I think we did about 2 more in the last class. So we'll cover these last 2 or 3 tomorrow, and I'll give you a handful of others that we can work on the back of that as practice. But there is an assignment open. Okay? Kind of attack that tonight if I need to, because we didn't get through as many examples as I'd like to. If we need to extend that assignment tomorrow, we can do that. But I do have a couple extra questions that I want to attach and attack tomorrow as well. Reminder, test on Friday. Okay, I will open an optional review soon.